Is this on? Yes, it is. Okay. Thank you for staying to the very, very end. We're going to try and keep this quick. Um, my name is Arie Hoeven. I'm a principal project manager with Seagate Technology. I represent, I'm going to say Seagate Technology, also IEEE 2883, also the Circular Drive Initiative. Like John Michael Hands, I'm very involved in circularity and sustainability across the industry. Today we're going to, really recap a lot of what's been talked about already today and probably correct some things from my deck. Because, I work closely with Shruti, I work closely with especially the embodied carbon group. But we want to bring up the concept of total cost of carbon ownership. We have for years talked about TCO at Seagate because storage is a large part of TCO. Our calculations are always wrong. They're always different than what the hyperscalers and OEMs come up with. So really, we're not going to try and claim we know anything. We're just going to try and start pushing this new concept, which I think has already, and Shruti already brought it up earlier. So let's try and go quickly. Same graph, only not as nice as what Shruti brought up, but there's an amazing global data explosion. The good news here on HDDs is if I were to hold up a 1 gigabyte HDD, which is the first one I owned from like 1996, and then 2 years ago I also held up an 18 terabyte drive, you would have to stack the 1 gigabyte drive 5 football fields high to match the capacity of that 18 terabyte drive, and today we're at 22 and beyond. So, on the HDD side, HDDs are not dead. And also the carbon impact, as you'll see later, if anything is going down, especially for embodied carbon, and of course we have to keep the same power envelope from generation to generation. So huge CAGR growth, and there's a lot of pressure. I mean, I'm really just repeating what we've been hearing today, so we'll try and go quickly here. If we look at what's coming internationally, from the Kyoto Protocol to the Paris Agreement to Glasgow, the pressure is coming from international agreements, it's coming from the boardrooms, it's coming from our customers. I can't stress this enough, and I think it's been stressed already today, but believe me, and I think others earlier did a great job of showing that we're above aviation now at the data center level for carbon emissions. So there are many paths towards storage carbon neutrality. For us, increasing HDD capacities. And I'll demonstrate how we're moving towards heat-assisted magnetic recording. HAMR is the next evolution. And that's actually a quick upgrade. So we're moving to like 30 and 40 terabyte drives that will have the same embodied and overall carbon impact as, say, a 2 terabyte drive. So it's just incredible what we're able to do on the HDD side. We'll look at SSDs, and I was very impressed with Solidime's presentation on QLC sustainability, and I'll apologize for another graph I'm going to show from a study. This is where I'll apologize, because this came from a paper called The Dirty Secret of SSDs Embodied Carbon, where it really shows that embodied carbon for SSDs does climb just because of the semiconductor manufacturing impact. And then if we look at our, and we work with a third-party company called Enthesis to do our life cycle assessments. And we've been able to drop, and I think this is really easy pickings. We've basically been looking at our suppliers and saying, hey, you have to go with renewable energy, for example, and better materials. So we've actually been able to reduce our embodied carbon quite a bit from our 8 terabyte drives to our 20 terabyte drives. And I don't mean this to, I don't want to create a competition between SSDs and HDDs because they serve different purposes. And I'll show this in a moment. This is just a look at one of our LCAs. And that red line, anything above that, I consider embodied carbon. Below that, use phase, if you're using conventional energy, not renewable energy, it's all use phase. But if you're using renewable energy, which we hope the world is moving to, then we look quite good on the HDD side. So I call this a false equivalency, because different workloads have specific latency and throughput needs. I think the Solidigm, I threw in QLC sustainability just because of what I learned today. So we're encouraging people to be really smart about how they tier their storage. We have a graph I'm not using right now, but it kind of shows, the spectrum of throughput to cold storage. And other things, we didn't mention tape today, but tape's in the game. We've got silica, we've got DNA storage coming. This is all important, but today it's mostly SSDs and HDDs. And you just need to use the right mix and think smartly. I tried to delve into that for this presentation, and that would be like an all-day seminar with dozens of companies. So it's just it's a big topic as to what storage you need to use to meet your needs, to meet the total cost of carbon ownership ideal spectrum. Now, we'll always focus, and we're very focused on driver use. And I gave a talk earlier in the security presentation, or the security track, on why we need to get past that high barrier we have for sanitization. And SEDs and crypto erase is a big part of that. But also, we're really encouraging people, and especially the hyperscalers, to get more involved in the IEEE 2883 movement or specification, which is kind of the gold standard for data sanitization, because there are tens of millions of drives each year that just get shredded. And we heard that earlier from Louis at Microsoft, and we have to get over that. There is a path, and sometimes you can come up with, like John Michael said, there's like a 1 in 100 million chance that some data gets through. We're getting to a point where it's ridiculous when you look at the other talks today, where they look at the global temperature rises and what we have to do. So we have to make really hard choices, right? And that's why I talked to the security group today, is that there we're kind of getting, Louis talked about his customers inside of Microsoft, and this is true across the industry. I'm not picking on Microsoft. I used to work at Microsoft. But we have to flip the bit. We have to think that you should get fired for for your carbon consumption, not for a minor security slip. If you're a VP. I'm not a VP, so it's easy for me to say. To put a positive spin on things, and this has been a big conference around AI, all this storage we're generating can do great things for human genomics. It can do, smart factories are so much more efficient. Autonomous vehicles, they're EVs. There is just amazing opportunities throughout the world for these technologies, and smart cities as well. So AI, even though it creates a lot of carbon consumption, and we see the data centers, moving up to what, 14% or whatever of global carbon consumption, there is a backside of that where they're actually reducing consumption as well. So we need to balance the two. We're looking for partners in sustainability. And these are groups for the most part, I am a member of IEEE 283.1. We want more participation there. There's a circular drive initiative. We have in the open compute sustainability group, there's a white paper on data sanitization for the circular economy. Get involved. And then, again, the Circular Drive Initiative, look at the members we have. What we don't have here is a major hyperscaler yet. They're sometimes participating in meetings. Thank you to the members who are here, including Solidigm. But this is really a big push, and we're kind of we feel like we're a guerrilla force. We're not inside yet. We're fighting, and we're fighting hard. Call to action, engage with these groups, engage with us, and invest in innovations. I mean, everything you've heard today here, actually, I can't really see anything here that hasn't been repeated. And what I want to thank you for is that there's a large group of here. I've spoken to smaller groups, and it's the end of the day at OCP. So thank you so much for your participation, and let me know if you have any questions. Thank you.
I like this idea about reuse and versus recycling. But obviously these things incur some cost. Do you have any idea about like what would be reasonable cost targets to make those solutions succeed?
Okay, so that's a great question. If we have a buyback program at Seagate, and we kind of start at, and it depends on the quality of the drive and the capacity. But if you sell us a drive that you've sanitized, we kind of start around $2 a terabyte. Now, if you have to work with an ITAD vendor or us, in a very specific case, the cost of recycling, responsibly recycling, getting all the materials back into the ecosystem is anything from $2 to $11 per drive. So that's quite expensive, although the gain is that you meet your zero waste goals. So that's the answer I can give right now.
Thank you.
All right, thank you, everybody.